All right, welcome to our explainer. Today, we're diving deep into the world of a microscopic master of disguise, a parasite that literally turns our body's own defenders into its personal Trojan horse. This is the incredible story of Leishmaniosis. So let's just jump right in with the big question. What exactly is this ancient disease, sometimes called black fever, and how in the world does it manage to so cleverly turn our own immune system against us? Well, to figure that out, we've got to understand the parasite itself.
And to really get a handle on this disease, first we need to map out its territory. You see, this isn't just some local problem. We're talking about a parasite with a truly global reach, impacting people across multiple continents.
Okay, so what is it? At its heart, Leishmaniasis is a disease caused by this tiny, single-celled parasite. And a couple of words here are super important. Intracellular, which means it lives inside our cells, and reticuloendothelial system. That sounds complicated, but it's basically just the network of immune cells in our spleen, liver, and bone marrow. And that is the parasite's #1 target.
You know, the history behind this is actually pretty wild. Think about this. Way back in 1903, in two totally different cities in India, two scientists, Sir William Leishman in Calcutta and Sir Charles Donovan in Chennai, independently identified this exact same organism at the exact same time. It's no wonder that today, when we see the parasite under a microscope, we often call it the Leishman-Donovan body, in their honor.
Now, this parasite isn't just everywhere, it has two very distinct territories. We talk about Old World Leishmaniasis, that's in Asia, Africa, and Europe, and it's transmitted by the phlebotomous sandfly. And then you've got New World Leishmaniasis over in the Americas, carried by a completely different vector, the Lutzomyia sandfly. So same disease, just different couriers.
But here's the kicker. The impact is not spread out evenly at all. Get this, over 90% of the most severe form of the disease, we call it visceral leishmaniasis, happens in just a handful of places. We're talking Southeast Asia, East Africa, and Brazil. It is an incredibly concentrated global health problem.
So, we know the what and the where. But the part that is just absolutely fascinating is the how. How does a single-celled organism outsmart a complex human immune system? Well, it uses a brilliant and, frankly, a devious strategy. It builds its own microscopic Trojan horse.
Now, to understand this whole strategy, you got to know that the parasite basically has two different forms. It's almost like two different outfits for two different occasions. When it's in the sandfly, it's called a promastigote. It's got this little tail-like thing called a flagellum, and it can swim around. But once it gets inside you, it does a quick change, transforming into the amastigote, a version with no tail that's designed for one thing and one thing only, hiding inside your cells.
So the whole heist begins with a simple bite. An infected sandfly injects those swimming promastigotes into your skin. And right on cue, your body's first responders, these big immune cells called macrophage, they show up. Their job is to swallow and destroy invaders. But here's the twist. For this parasite, that's exactly what it wants to happen.
Once it's been safely swallowed by that macrophage, the parasite performs its magic trick. The promastigote sheds its tail and morphs into that stealthy amastigote form. And then it just starts to multiply. Over and over and over again, completely filling up the very cell that was supposed to destroy it. And this just perfectly illustrates the core strategy. That macrophage, your own immune cell, becomes the Trojan horse. The parasite hitches a ride inside, totally protected from the rest of your immune system. And when that cell is packed to the brim, it bursts, releasing a whole new army of amastigotes to go and infect even more cells, letting it spread all through the liver, spleen, and bone marrow.
But wait a minute, how does it pull this off? How does it survive inside a cell that is literally designed to digest it? Well, it has a secret weapon, a kind of molecular invisibility cloak called lipophosphoglycan, or LPG for short. This molecule coats the parasite and acts like a shield, basically deactivating the macrophage's internal weapons. It is an incredible piece of biological engineering that makes this whole heist possible.
Now, this microscopic battle isn't just some abstract science story. It has very real, very visible consequences. So let's take a look at the three main ways this disease actually shows up in the human body.
The infection can present itself in three main ways. The most severe is Visceral Leishmaniasis, also known as Kala-Azar, where the parasite invades the internal organs.
Then there's the most common form, cutaneous leishmaniasis, which causes these nasty skin ulcers, often called oriental sores. And finally, there's something called PKDL, which is a skin condition that can actually appear after a person has already been treated for the visceral form.
For that most dangerous form, Kala-Azar, doctors look for a classic set of 5 clues. It's called the pentad. A fever that just won't go away, serious weight loss, a swollen spleen and liver, a big drop in all your blood cell counts, and a massive spike in antibodies as your body tries desperately to fight back.
So, with a parasite this good at hiding, how on earth do you actually find it? How do you detect an enemy that's hiding inside your own army?
Well, the absolute definitive proof, what we call the gold standard for diagnosis, is to actually see the enemy. This means taking a small sample, usually from the spleen or bone marrow, putting it under a microscope, and physically finding those little dot-like amastigotes, the Leishman-Donovan bodies, hiding right there inside the macrophages.
Of course, that's a pretty invasive procedure, so thankfully we now have much faster, more modern tools. There are rapid diagnostic tests, like the little RK39 strip, that can detect the antibodies your body is making to fight the infection. And then there are super-sensitive PCR tests that can detect even the tiniest traces of the parasite's actual DNA. Okay, so we can find the enemy. But as we all know, finding it is only half the battle. How do we actually fight back against a parasite that is so perfectly adapted for survival? And how do we win?
For a long time, some of the main treatments were starting to fail because the parasite was developing resistance. But today, the drug of choice, our heavy hitter for the severe visceral form, is liposomal amphotericin B. It's a really powerful and effective weapon to have in our arsenal.
But it's not our only weapon. That arsenal also includes drugs like miltefosine, which is great because it's a pill you can take, and paramycin. In fact, to stay one step ahead of the parasite, the World Health Organization often recommends using a combination of drugs at once. It's a smarter strategy that improves effectiveness and helps prevent resistance.
But at the end of the day, treatment alone isn't enough. Winning the war means preventing infections from happening in the first place. And that really comes down to public health basics, controlling the sandfly population and making sure that anyone who does get sick is diagnosed and treated fast. That's how you break the chain of transmission, and it's a key goal of major efforts, like India's National Control Program.
Which really just leaves us with one final thought. This parasite has been locked in an evolutionary arms race with us for thousands and thousands of years. It has perfected the art of hiding. So as our science gets smarter and our drugs get better, the question is, how will this ancient enemy adapt next? What new tricks will it learn to continue its strategy of hiding in plain sight?